Welcome to Hadoop Fundamentals. And now we're going to talk about how we're going to define Hadoop, which is a bit difficult to do because a good working definition of Hadoop is it's a framework of tools, libraries, and methodologies. So it's not one thing you can download and say, I have Hadoop. There's lots of pieces to it, and we're going to touch on a few of those in this tutorial. The thing to also understand about Hadoop is that it's an open source package, which means that no one can control the source code and it's available to anybody. And this guarantees that the Hadoop community and those, the users, actually can have control of the source and can't be locked in by any one particular vendors. Although there are some vendors that do offer commercial additions and improvements. The other thing to remember about Hadoop is it's a simple programming model. Fundamentally, it uses a MapReduce model, which is actually fairly simple and solves a lot of the issues involved with doing parallel computing. It's also very scalable, from a single server to thousands of machines. Hadoop was designed to use commodity hardware, and this means it can be used in the cloud, it can be used on a single machine, or it can be used on a 1,000-node cluster, rather, that you would have in your organization, or any size in between. Because it uses commodity software and hardware, it's also got a built-in level of fault tolerance. And what that means is, since clusters can get large and servers will fail, there's application-level fault tolerance built into Hadoop, so things can fail and things will keep working. And finally, the other thing about Hadoop is there's some core pieces to it, which are the Hadoop file system and MapReduce. And then there's many other tools and libraries that have been built into Hadoop, either by the Hadoop authors or as part of the contributions from people that have added to the package. It should be noted from the beginning here that because it is open, an open source and open documentation project, that virtually all of Hadoop that we'll be talking about in this tutorial is under the Apache Hadoop project, and also goes to mention that there will be Apache Hadoop documentation and items I may talk about in this tutorial, and I wanted to give some acknowledgments and attributions. So essentially, Apache Hadoop is responsible for distributing the software and a lot of the documentation, and thank you to them. Yahoo, which originally developed Hadoop and donated it to the Apache Foundation, also has lots of materials for Hadoop, and they're under Creative Commons license, as does Hortonworks. And we'll be talking a lot more about the Hortonworks data platform later, and that's all under an Apache 2.0 license and a Creative Commons license. So I'd like to thank all these organizations for their contributions to Hadoop and the Hadoop ecosystem and their continued support and development of these projects. I'd like to explain what I consider Hadoop usage modes in the context of this tutorial. Like most big computer applications, there's administrators and end users. In general, administrators of Hadoop will handle installation, monitoring, and managing the system and tuning the system, while end users will design MapReduce applications, import and export data, and work with various Hadoop tools. In this tutorial, we'll cover both of these aspects, and indeed with Hadoop, many of these aspects overlap each other, and an end user may actually be very much involved with tuning the system in a sense of getting it to work better and working with an administrator and so forth and so on. An administrator may help get an end user's application working on the system because of some dependency of some sort. So right now it's a very dynamic ecosystem, and the traditional usage modes apply, but they come in at different angles. And we'll talk about both end user issues and administration issues in this tutorial. Hadoop has an interesting history. It was developed by Doug Cutting and Michael J. Caffarella. And interestingly, Doug Cutting's son had a toy stuffed element which he named Hadoop, which Doug then co-opted for the whole project. Hadoop is based on the famous Google MapReduce technology that they've implemented to do their web indexing and searching. The idea behind Hadoop, however, is to have an open source, community-based big data application that can be used for doing MapReduce problems. And it was designed to handle, as with Google MapReduce, large amounts of data and be very robust. And we'll talk about some of these issues a little bit more later. It was donated to the Apache Software Foundation in 2006 by Yahoo. Some areas where Hadoop is used are things like social media, retail, financial services, web search, government, and pretty much everywhere there's large amounts of unstructured data. Some of the prominent users you may have heard of, and I've listed some of them here below, like Yahoo, Facebook. Some of the others you may not have realized: the Federal Reserve Board of Governors, Chevron, IBM, and many others are also using Hadoop in their back-end data management facilities. Let's take a minute now and define what we mean by big data. In general, big data fits into these categories, and there may be others, but this generally defines it. So big data is usually large and growing data files, and they're commonly measured in terabytes, that's 10 to the 12 bytes, or petabytes, 10 to the 15 bytes. So these are extremely large data sizes. It's usually unstructured data, which means it doesn't fit into a relational database model as easily as one would hope. And it's derived from things like users, applications, systems, and sensors. And in our ever more connected world, the amount of data that we're collecting and is available has been growing tremendously. And it can include things like video, audio, web information, stock transactions, public records, even the human genome is a big data set. So it covers a vast array of topics and areas, and the size of files and the amount of data continues to grow. One of the issues that is facing modern computing is what I call the data throughput mismatch. And if we just do a very simple-minded analysis here of current technologies, we'll see what I'm talking about. So if you generously consider a good spinning hard drive, traditional hard drive, that can deliver 60 to 100 megabytes per second. Streaming, not random. And the newer solid-state hard drives can deliver 250 to 500 megabytes per second, and that can be streaming and random because of the solid-state technology. Essentially, though, if you look at all the technology curves, hard drive speeds in terms of data delivery, reading, and writing has been relatively flat. Hard drive capacity, on the other hand, has continued to grow, and right now the 4 terabyte drives are available at the consumer level. Online data growth continues to double every 18 months. And as we all know, processor speeds, performance, etc., has been making similar gains with the addition of new extra processors and multi-core packages. So the amount of processing available continues to grow, even though the actual speed of the individual cores may not be increasing like it used to. So what we find looking at this data, the real difficulty is, and bottleneck, is moving data on and off of the disk. Everything else seems to be growing nicely, but when it comes to moving data to and from disk, we have a little bit of a bottleneck. Let's take a look at a simple example. A 1 terabyte data file will take 10,000 seconds, that's 167 minutes, to read at 100 megabytes per second on a spinning disk. And that's assuming everything's perfect and we're going to be hitting 100 megabytes per second, which anybody who uses this type of equipment knows that that's on a good day. Similarly, we can do this with solid-state disk, and we would see that the same file would take 2,000 seconds, about 33 minutes, and if we could achieve 500 megabytes per second continuous. The interesting thing in the big data world, a terabyte size file is sometimes considered a small file. So even if your small files on your best day take 33 minutes to read through, and you need to do some analysis very quickly on several of these size files, you can see how this mismatch is really going to slow things down. Now, of course, there's things we can do with RAID and adding more I/O controllers and things of that nature, but essentially we're going to hit some sort of bottleneck on a single storage device. So the need for parallel data access is essential for big data, and that means the way Hadoop does it and most other MapReduce operations is they break the data up into various pieces and do individual searches on the pieces of data and then combine the results. In Hadoop terms, what that means is we move the computation to the data rather than trying to move the data to the computation. So it allows us to take advantage of the best speeds we can get out of the hard disk drives and moving the computation to where the data lives. And this is the key aspect of the whole Hadoop and big data methodology.